Okay. Assalamualaikum warahmatullahi wabarakatuh and very good morning. Today we're going to continue our proceed with our chapter one for subject making of machine. And by this time, I'm going to proceed with the topic of lifting machine with balancing mass. So as we know, this chapter basically we're going to cover with what you call that with the hoist system. So as I mentioned earlier, hoist it got four situations. One with the ascending, situation two is descending, situation three is a free fall. Eh? No, the situation three is a descending with a uniform velocity. Situation four is a free fall. And lastly, is what we are going to cover now, which is a lifting machine with balancing mass. Okay. So as you can see now, this is the lifting machine with the balancing mass, and here is the free body diagram. Free body diagram. Okay. So as you can see now, there's a two masses. There's a two mass on the right on and on the left rope. So we got one mass and then the second mass. Okay. Which is labeled as a M1 and labeled as a M2. Okay, since it connected to a rope, one mass move downward and another mass going to move upward. Yeah. So here you can see the direction of the motion. You see the arrow. So for the mass one, basically it's going to move upward, while the mass two is having a motion to the downward direction. As you can see, the what you call that, the arrow is pointing downward. Okay, then in resolving the problem, we will separate the diagram into three sections. So we got this one is the first section. This one going to be second section, and this one will be the third section. Okay. So as we can see, the first section is the linear motion. Basically, the first section and the second section is the linear motion. So it moves linearly, and of course, the third section is going to move angularly. Okay. So for the linear motion, as you can see, P1, which is representative of the load acting towards the mass 1, is shown to be equivalent to M1 here. P1 equivalent to M1 multiplied by G plus with M1 multiplied by A. It's normal lah. And then P2, since it moved downward, so you're going to have a minus sign for the MA. As we know here, acceleration is going downward. Therefore, wait up. As the acceleration going downward, therefore, you're going to have a reflect the reaction forces, which is against the acceleration. So we're going to have mass 2 multiplied by acceleration at mass 2. So here you go. So basically, for if you got two system, which you got two mass, you got two weight, so you're going to have two equations, which is the linear motion. At the same time, if you got angular motion, okay, we got one pulley. So basically, you can have the whole thing here. As you can see, P2R here. P2R is basically anti-clockwise. Okay, plus with torque, following anti-clockwise, and then any what you call it, any variables that following the anti-clockwise motion? I think we don't have. So for this case, for the anti-clockwise, we got basically we got P2R. Okay, that's better lah. Okay, P2R, and then we got torque. This one is anti-clockwise. However, for the case of clockwise, following the clock, clockwise lah, ikut jam. So basically, saya padam dulu yang FDB . So basically, for this case, you got TF plus with I alpha, okay, and plus what else you got? Here you got tension of the rope for system 1 and its resistance. Okay, so this is two components. One is anti-clockwise, another one is clockwise. So you're going to equate it like this, and then you're going to rearrange it to make it in the function of torque or torsion. So for this case, you're going to get P1 R plus I alpha plus TF minus P2 R. Again, a great reminder, R here, it means to be resistant, not the radius. Okay, so this is the basic of the lifting machine with the balancing mass. It means this is the fundamental for you to understand. So since we still dealing with two type of equation. One is a linear motion, another one is angular motion. However, eventually for this linear motion, we got two system, or we got two mass. So therefore, we want to produce, or we want to derive two equations. Okay. So we go for example 7, right? Basically, it state here, a lifting machine is required to lift a load of 450 kilogram and with an acceleration of 2.4 meter over second squared. So basically, a lifting machine is required to lift a load. So which one? If you put it this way, this one lah. Okay, since it lift up, the balancing mass of 150 kilogram is placed on the side of the rope. This one is the balancing mass. There is a wound or support on a drum. So the drum is here lah. So yeah. So this one is this is drum. Okay, this one is balancing mass. Okay, this is your lift. As we know that the lift basically is moving upward, since you know the motion is moving upward. So when the lift is moving upward in the upward motion, so the balancing mass supposed to be in the downward motion. Right? So you're going to go by this, right? Okay. The drum diameter is 900 meter and 900 millimeter. Of course, the drum is is 900 millimeter, and radius of gyration K is equivalent to 370 millimeter. And we got mass for the drum. We got mass. Mass is mass drum is equivalent to 60 kilogram. It highlighted here. You're going to neglect the friction. Yeah, you are neglecting the friction lah. So it's a frictionless. There's no friction. Yeah. Neglecting the friction. Determine the tension of the rope at both sides. So basically, they want to know what they want to know. They want to know P1 and P2. We don't know. And of course, they want to know the drive torque and power produced by the drum. So the drive torque is, they want to know T and P with a velocity of 1.8 meter over second. So this is the whole thing lah. So first and foremost, basically, you're going to find I, and we know I drum is equivalent to 60 kilogram multiplied by K, radius of gyration, power of 2. Yeah, this one. I'm going to find this one first. Okay, power of 2, then you got 8.214 kilogram meter squared. And then you're going to find the angular acceleration, which is alpha. Okay, alpha. Alpha is equivalent to A acceleration over R radius. Okay, R is the radius of this one. R is the radius of your drum. Okay, R is the radius of your drum. Here, R equivalent to, what is the radius of your drum? Your drum diameter is 450 millimeter. Yeah, since the diameter is 900 millimeter, so you need to divide by 2. You're going to get 150. Okay, so overall, in overall, your angular acceleration is 5.3 radius per second. Here, 5.3 radius per second. So first thing first, in order to get the tension of the rope at the both side, basically you're going to state it lah, everything here. So we know the formula, which is here for the motion that moving upward, and this one is for the motion that moving downward. Okay, this one is downward. So you're going to equate, then you got 5494.5 Newton, about 5 kilonewtons lah, yeah. And this one we got about 1 kilonewton. Okay, just insert all the numbers into the equation, then you're going to manage to get those P lah. This one P1 and P2. Okay. This one you solve it throughout. You solve it throughout a linear motion of equation. So you manage to get the answer, to get the result. Okay. Therefore, example 1A is done. Okay. So now, you want to find the driver torque, you want to find the power with the velocity of here. How to solve the problem? Okay. In order to solve this problem, this is the formulation lah. The driver torque and the power produced by drum at the velocity of something is, of course, you're going to equate this sort of equation. Simple lah. Okay. So you're going to rearrange it. Okay. Then you got P equivalent to P1 R, which is resistance, minus with P2 R, and then plus with IA. Then IA, you already got, you already know the I and you already know the alpha. So you just multiply it. So this one supposed to be, settled. You know that one. P2R, you also know, and P1R, you also know, since you already knew this one. P2 is equivalent to P2R radius. Sorry, P2R resistance. P1 equivalent to P1R resistance. Okay. So that's why you got this one. And then you just multiply it, then you got the answer here. Okay. And then once you already know the T, okay, so the formation for power is T power equivalent to T omega. Okay. So you multiply it, then you know lah. You already managed to get the answer lah. Okay. Okay, so this is one of the equation, yeah. One of the way to solve the equation. Okay. So you see, a steel drum of the machine has the weight of 120 kilogram, a diameter of 2.2 meter, and a radius of gyration of 0.44 meter. At the end of each rope is suspended with a mesh lah. Yeah, you got both here. Calculate the torque required to lift up the mesh. Okay, so same goes lah. So for me, I think it's a very straightforward lah, yeah, for you to solve the problem, yeah. So as a similar example as been stated previously, I think this one going to be much more easier for you lah, to solve it. Okay, and same goes by this question as well. Okay, so that's it from me. So now I already covered the section, the chapter 1. So we're going to discuss further lah next week. Okay. Assalamualaikum warahmatullahi wabarakatuh. And very thank you.